Today we're going to be learning about how to simplify rational expressions. So first off, what does the word rational mean in math? It means it is a number that can be written as a fraction of two integers. So these kind of numbers include something like 1/2, which we could also write as 0.5. So both of those are rational numbers. Or we could write the number 2 as being 2/1. So 2 is a rational number. Or 0.3 repeating is rational because it can be written as 1/3. So a rational expression is an algebraic expression in the form of a fraction. So an example of that might be something like 1/x, or maybe 2x over x plus 4. So there's just an algebraic expression that is involved with being any fraction. So in this unit, we're going to learn how to simplify, multiply, divide, add, and subtract rational expressions. The first thing that we have to learn how to do is how to simplify a rational expression. We can simplify when the numerator and denominator have the same factor. When there is a common factor, it can be canceled out, just like simple fractions. So if we know we have 8/10, we know 8 is really 2 times 4, and 10 is really 2 times 5. So what we can do then is cancel out the 2's. We can do that because 2 divided by 2 is just 1. So anytime there's a fancy form of 1, we can just cancel it out. So then we are left with 4/5, and that's our answer. If we have something similar, but now we have algebraic expressions, we have an x plus 3 on the top over x plus 3 on the bottom. So what we can do, we know x plus 3 divided by x plus 3, well, anything divided by itself is just 1. So this is really just like a fancy form of 1, which means it cancels out. So all that we are left with is the x minus 1. Now, it's important to remember that we are only allowed to cancel when there is a common factor. We can't cancel if it's part of a sum. So even though we have an x squared and an x squared, we can't cancel these because it's part of a sum or a subtraction. What we can do, since this is multiplication in between, anytime we have multiplication, we can cancel these two and then simplify. So now we're going to try a few examples, and one thing that we're going to do that it might ask you to do is state excluded values. So we'll find out what that means in a second. So the first step to solving these problems is trying to factor and see if we can find a common factor in the numerator and denominator that we can cancel. So in the top, we just have a plus 4 for this first example. And in the bottom, I can try to factor out the GCF. So both of these have a 2 in common, so I can take out a 2. And I can also take out an A. And then I'm left with a plus 4. Now notice I have an a plus 4 on the top and an a plus 4 on the bottom that are being multiplied, so I can cancel them. When I cancel, it doesn't turn into 0, it turns into a 1. So on the top now, instead of just having nothing, I have a 1 over 2a. Now the last thing we have to do is state the excluded values. So we need to figure out at any point, could I plug in something that's going to make the denominator 0? So the denominator cannot be equal to 0. So at any point, I'm going to look at this factored thing right here. and see what I could plug in that would make it 0. Well, I know if a is 0, the whole thing turns to 0. So a can't be 0. Also, this a plus 4 can't be 0, which means a can't be equal to negative 4. So I can figure out what can't be 0 by setting the a plus 4 equal to 0. So a can't be negative 4. Let's try another example. So in this case, let's try to factor. So I'm going to factor out a 4 in both cases because 4 is the biggest number that goes into all of these numbers. So I'll take out a 4 from the top, and I'm left with 10x. I'll take out a 4 from the bottom, and I'm left with 5x plus 4. Now, I'm going to see what I can cancel. I can cancel out my 4's, and I'm left with 10x over 5x plus 4. Now again, my denominator cannot be 0. So that means my denominator here can't be 0. So 5x plus 4 cannot be 0. Now I'm going to solve for x. So I'll subtract 4 from both sides, get 5x equals negative 4. I'll divide both sides by 5 to get x equals negative 4/5. So x cannot be negative 4/5 because if it is, my denominator is 0 and I cannot divide by 0. Next up, you might see something that involves polynomials. So what we're going to do is factor. So I'm going to rewrite this as what multiplies to c and adds to b. So in this case, we get x minus 9 times x plus 2. And now what multiplies to negative 45 adds to negative 4. Well, that's going to be x minus 9 times x plus 5. Now notice these two factors cancel out on the top and bottom. So all I'm left with is x plus 2 over x plus 5. And lastly, I just have to make sure my denominator can never be 0. So this can't be 0, and this can't be 0. So if x minus 9 can't be 0, that means x cannot be positive 9. X plus 5 cannot be 0, means x cannot be negative 5. So there's my two excluded values, because if I plug those back in, they would make me divide by 0, which I cannot do. Let's try this last problem. So I'm going to factor again. So I'm going to take out an 8 on the top to be left with p plus 10. And on the bottom, I'm going to factor. So I'll get p plus 10 times p plus 10. Now notice in the numerator, we only have one p plus 10. In the denominator, we actually have 2 of them. But I can only cancel one set. So just because I have 2 in the denominator does not mean I can cancel both. Because I know p plus 10 divided by p plus 10 is 1. So I'll just cancel one pair. And I'm left with 8 over p plus 10. And lastly, my denominator can't be 0. The number I could plug in that would make it 0 is negative 10. So p cannot be negative 10. And that's how you simplify.